Welcome, everyone. Today, we're going right under the hood of the most powerful AI systems on the planet. We're going to tear down the engine together and figure out exactly how these incredible tools actually operate. No jargon, just the real mechanics. So, it really is the central question of our time, isn't it? How do these chatbots actually work? Because let's be honest, when you type a prompt into a chat window and get this brilliantly structured, highly nuanced essay mere seconds later, it absolutely feels like there's a little human brain sitting inside the server thinking and reasoning just like you and me. But today, we're going to completely shatter that illusion. Okay, let's dive into this, because looking at our source material, the fundamental truth of the matter is that at their very core, large language models, or LLMs, are just giant statistical prediction machines. They literally do not know the final answer before they start typing. Instead, based on billions of parameters and just oceans of training data, they are simply and repeatedly predicting the most probable next word in a sequence. That's the whole secret. It's math, not magic. To make sense of this, here is our roadmap for the explainer. First up, predicting the next word. Second, inside the transformer engine. Third, learning from human feedback. Fourth, experts and thinking models. And finally, the big 2026 showdown, ChatGPT, Gemini, and Grok. Let's kick things off with Section 1, predicting the next word, the raw materials of AI. You see, before an AI can predict anything at all, we have to prep the raw materials. AI doesn't actually read English or French or Spanish. It reads tokens. Tokenization is basically the process of chopping your prompt down into smaller machine-readable units. Now, this might be whole words, but a lot of the time it's just subwords or even individual characters. Doing it this way standardizes language, which means the model can easily handle rare words, weird typos, and completely novel phrases without breaking a sweat. Once we've got our tokens, we have to actually give them meaning, right? And we do that through something called embeddings. This is where tokens are mapped out to vectors, which are basically just long lists of numbers inside this massive multidimensional space. By doing this, the AI learns semantic associations. Think of it like a giant map of meaning. For example, if we're dealing with a text about a forest, the math will group the vector for tree and the vector for bark really close together. But shift the context to a canine, suddenly dog and bark are placed closer together. The numbers perfectly capture the context. Moving on to Section 2, inside the transformer engine, the core architecture. So we have our tokenized, embedded raw materials. Now we need an engine to process them. And literally everything in this field changed back in 2017, when Google researchers published a totally groundbreaking paper called Attention is All You Need. Now, what's really interesting about this slide is how incredibly intimidating the 2017 transformer architecture diagram looks at first glance. You've got this encoder stack on the left, a decoder stack on the right, all these feed-forward networks. It's a lot. But don't let it overwhelm you. We can actually break this whole thing down to its most brilliant, beautifully simple underlying component. The absolute genius of the transformer is a mechanism called self-attention. Imagine you're reading a really long paragraph. By the time you get to the very last sentence, the word "it" might refer to a noun that was mentioned 3 sentences ago. Well, self-attention allows the AI to calculate the relationships and dependencies between all the different tokens in a sequence simultaneously, no matter how far apart they are. It creates these weighted connections, so the model knows exactly how much attention the word "it" needs to pay to every single other word in that text. To really grasp why this was such a game changer, you just have to look at what came before. Prior to transformers, we relied on recurrent neural networks, or RNNs. Now, RNNs had to read text sequentially, step by step, strictly left to right. It was super slow, and honestly, they'd often just forget the beginning of a long sentence by the time they finally reached the end. Transformers, on the other hand, process the entire sequence in parallel. This unlocked just unprecedented computational efficiency, meaning overnight we could suddenly train models on datasets that were billions of times larger than anything we'd ever done before. Which brings us to Section 3, learning from human feedback, training the AI to act human. Okay, so we've built this incredibly fast prediction engine, but here's the catch. An engine that just predicts the next word based on the raw, unfiltered internet is probably going to give you toxic, highly biased, or just utterly unhelpful answers. So how do we shape it into a helpful assistant? We use a pipeline called reinforcement learning from human feedback, or RLHF. First, we pre-train the model on a massive chunk of the internet so it learns basic grammar and facts. But then, real human annotators literally sit down, look at different answers the AI spits out for a single prompt, and rank them from best to worst based on helpfulness and safety. Finally, we use reinforcement learning to fine-tune the model so it consistently favors those highly ranked, human-approved behaviors. But the absolute crucial point here is how on earth we scale this up. You obviously can't have a human being review every single output during training. That would take millennia. Instead, those human rankings are used to train a completely separate reward model. And this reward model acts as a mathematical proxy. It's basically an automated stand-in human judge that rapidly scores the AI's outputs during that final reinforcement learning phase. It teaches the AI our exact preferences without us ever needing to hand code impossibly complex human values into a rigid math formula.
Next up, Section 4, Experts and Thinking Models, Scaling for Speed and Logic.
So here we are in 2026, and these models have gotten so ridiculously massive that just throwing more raw hardware at them simply isn't enough anymore. One of the biggest leaps forward is the shift from standard neural networks to mixture of experts, or MOE architectures, which is exactly what's under the hood of Grok 1.5. Think about it. In a standard model, every single parameter fires up for every single word you type. That takes immense computing power. But an MOE model divides its neural network into specialized experts. When you send a prompt, a routing network quickly decides to only activate a tiny fraction of the total parameters, just the specific experts best suited for your query. This massively increases the speed of the output without melting the server racks into a puddle.
We are also seeing massive leaps in how models literally think. And this is driven by algorithms like GRPO, which powers models like DeepSeek R1. Remember that reward model we just talked about? Well, GRPO often bypasses the need for a separate human-trained reward model entirely, especially when it comes to math or coding. Instead, it samples multiple complete reasoning traces for a prompt and checks their verifiable correctness directly using pure logic. This allows these models to genuinely reason their way through multi-step problems, rather than just guessing what sequence of words sounds the most human.
And finally, Section 5, ChatGPT, Gemini, and Grok, the 2026 showdown. All right, so we know how the raw materials work, we understand the engine, and we've seen how they scale. Let's look at the current landscape, comparing ChatGPT's GPT 5.5 Pro, Google's Gemini 3.1 Pro, and xAI's Grok 4.20. And this brilliantly illustrates a really important takeaway from our sources. There is simply no universal best AI anymore. There's only the best AI for your specific workflow. Let's break down exactly why that is. Let's start over with ChatGPT. In 2026, GPT 5.5 Pro is just the undisputed heavyweight champion when it comes to coding benchmarks and logical structure. But its true superpower right now is agency. With their new computer use feature, ChatGPT can literally view your screen and take physical actions inside your other software. When you combine that with the Codex agent, which can autonomously automate multi-file workflows, ChatGPT is hands down the ultimate choice for developers and anyone doing complex, structured automation. Then we have Google's Gemini. Its absolute standout capability is this monstrous 2.1 million token context window. Just to put that into perspective, you can literally drop 50 long, dense PDF reports into Gemini all at once, and it will reason across every single page without losing its train of thought. It's got native integration with Google Search, making its autonomous, deep research agents just incredible for heavy fact-finding. Plus, it currently holds the industry record for reasoning and can even spit out animated data visualizations. It trades a little bit of creative flair for highly cautious, incredibly accurate, and deeply researched output. And finally, we have Grok. And Grok definitely plays by its own rules. Its ultimate advantage is a direct, native pipeline right into the X live data stream, meaning if news breaks anywhere in the world, Grok knows about it hours before its web-scraped competitors even wake up. Version 4.240 uses this really fascinating four-agent parallel debate system to internally check its own answers, which has reduced hallucinations by a massive 65%. It's punchy, it's totally personality-driven, and it is uniquely capable of analyzing real-time sentiment and live social trends the second they happen. But as we wrap up this deep dive, it is absolutely vital to remember one ultimate reality derived from all our sources today. AI chatbots, no matter how ridiculously advanced they get, basically just generate output. They are the brains of the operation. They'll hand you the text, the code, or the data, but they do not execute your end-to-end business operations. Good old-fashioned human effort or dedicated AI workflow platforms like Sintra AI are still totally required to take that AI output and actually ship the work into the real world. The AI assembly line is no longer a mystery. we've seen exactly how the magic trick works. So, as these models continue to evolve from simply generating text to autonomously executing your daily tasks, which AI will you hire? Think about your own workflows, keep experimenting, and I'll see you in the next explainer.